you, I'll let them go first.
I have one ready. For your physical testing, did you guys test any different types of welding joints, and have you done a weldment test?
No, not yet. So we are designing a weldment structural integrity test that's actually outlined in the rule book, and we're going to be doing some different welds on them, some complete full penetration,
crappy welds.
Yeah. So we can get a full range of data for the welds.
We're going to be using the tensile machine provided by the college to do this test.
When do you plan on having that done?
I would like it done by end of winter break, depending on how much time we have between, like how many delays we have between getting our parts machine. Because right now we're having more delays with our pipes being bended, even though the tubes are ready to be gut. So just depending on how that is laid out, we can get started on the weldment test. And if everything comes in and we get it put together, we would probably shift our gears a little more towards actually manufacturing the chassis to make sure we reach that deadline.
Who's doing your tube bending?
Houston Pipe Vendors.
Are you going to be there when they do it?
Have not discussed that actually.
I'm just saying, because just from experience, when we didn't use anybody, we went and did it at yeah.
Oh, okay.
I don't know how they're going to do it. You send them drawings and stuff?
Yeah.
How did you distribute the force through your control arms when you were doing your FEA?
Did not actually calculate how the force was distributed through the material. We didn't have that data yet, but we just assumed that it would be conservative to divide it by the number of connection points of the control arms. Yeah.
It's not a bad way. Just maybe before competition, come up with a solid argument.
Yeah, we want to have the entire suspension package, have FEA done on that, and then actually see what the exact force is going through the control arms, and then apply that to the chassis and see how it.
So on that, what you said, Erica, about how you found out the 200 pounds, that was great.
Yeah.
I thought it was perfect. But you need to discuss why it's important. They ask that.
Over and over.
Why do you need torsion testing? What does it test? Can you go back to version 8, the slide, the FEI testing? Yes. So where did you load it at? Where did you fix it at?
This one was, go back to the FEA test. It was this one right here. So version 1 used test 1, version 2 used test 2, and then all the rest of the versions after that used test 3, and we hadn't quite gotten to figuring out where we wanted to fix the fourth.
We've been like evolving to a more accurate test.
We're looking into doing a dynamic testing on SolidWorks and Abacus.
Oh, something I didn't mention actually. Every single version that we did test, we tested in both Abacus and SolidWorks. SolidWorks would always give higher stress values, so we went with those just to be more conservative.
Okay.
Have you thought about how you're going to physically do that?
We've been brainstorming.
Yeah, we've been doing a little bit of research on the actual torsion testing. We definitely want to do it on the ground. We've been looking at a way to do it on the ground because we had issues with the table flexing and just other things flexing, and just looking at the errors of the mini truss experiment. So we'll be designing that over winter break.
We want to use more dial indicators for sure, and then we also want to make sure we're testing from the hubs this time.
Yeah.
It's
Yeah, we were debating.
If you're going to physically test it from the control arms and the hubs, you need to do it in a simulation that way as well.
Yeah, absolutely. We wanted to actually do a physical test without the hubs and with the hubs, just to see what that difference was.
Because when we did it, they questioned we didn't do it with hubs or
Right.
They questioned why you didn't do it.
Yeah, but then you have to figure out a way to make your control arms just trusses. And don't use obviously your actual control arms, just to make sure that you're not distributing any of the forces incorrectly.
Right.
So you're just looking at the chassis itself.
And we couldn't get to work.
Yeah. So I mean, it's
Yeah,
your challenge.
we're trying to do that right now. We're having issues with the tabs and mating them to just running the FEA with the chassis and the tabs and the control arms and everything on it.
Yeah.
So we're still working on that.
Have you guys done a full version of the chassis with all the components?
We are working on that right now.
Okay.
Yeah, each from version 6 to 8, we started to make a full assembly, but then every time a new version come out, we would start again. So 8, what's the deadline for that, for the full assembly for version 8? November 30th.
November 14th, this coming Wednesday is when we should have the model done. We'll be able to testing and finish integration by the
Is somebody controlling that master assembly? Are you doing it on chip?
Yes.
I think that's really important. Like you should already be doing that. Because
Yeah.
I think it helped us a lot in the end game.
We've had it with different iterations of the chassis.
Okay.
We're just with this final version, we're trying to have everything in by Wednesday.
Okay.
It's actually helped a lot doing it like
Way early.
partially because we noticed a lot of integration issues
Oh, yeah.
early on and some design issues and things like that. So.
Can you go, I don't know what slide it is, but it's when the redesign for your differential mounting.
That's version 8.
Have you, oh, actually, it's, okay.
Oh, it was in lessons learned. That
Yeah.
shows
Oh.
it better. Yeah.
Have you considered, have you taken into account like shifting it to the left side of the chassis and then also the chain? Just to make sure that you're not hitting anything as far as,
Yes, it is actually offset. You want to?
Yes, actually, it is already offset, and we accounted for that so that there is a space on the left side towards the bottom so that the sprocket, chain guard have enough room
Okay.
to rotate.
okay.
And yeah, it doesn't look like it, but it is not completely centered. It's about an inch inwards towards the left.
Okay.
So you're mounting to those two bottom bars.
Yes.
Can you point to it?
Oh, we're mounting there, okay.
Have you done analysis on that?
We've done very rough analysis with not specifically calculated values from the differential. Like we just applied.
That's the dynamic testing you're talking
The dynamic testing is more in terms of how the car going on a track. So not the diff.
about? I don't think that's important.
Yeah.
I think that's more important because we had a lot of trouble with that.
Yeah.
So we did, honestly, a huge driving force for every single version we had was we applied a force this direction, and we're designing around that based on last year's deflection.
Yeah.
So we were actually, that was kind of driving our entire, like where we wanted to strengthen the most. And then after the design freeze for the other subcomponents, we found out that it was going to be mounted from the bottom. And since then, we have not really perfected like the types of forces that we were using. So far, we were using a resultant of 500-pound force, but we haven't gotten a very specific value.
We're still waiting
for
on
that.
calculations on that. There's some
I
calculations.
don't think it's the peak force that's going to get you. It's the
The
dynamic.
Fatigue.
Yeah, we're also
another-
looking into doing fatigue analysis for sure on the differential mounts.
And
Well,
the
it's
seat and the engine, that's something we're
the
doing
seat,
after.
the bar that actually helps support the driver. I know that we had issues with that last year of fatigue. On
Are
that,
they going to
so
talk
we-
about the mounting for the differential? No.
Maybe power and drive line. I think they might talk about it.
Yeah, you'll probably hear it again.
Have you, do you guys know how you're mounting and where the shifter is going to be?
Yes.
Go back to 8.
MMI, are y'all going to talk about where the shifter's mounted?
Briefly.
Okay.
Did you have any questions, Andrew?
Yeah, my question was, you said your helmet was 4 inches away from the line, right? Can you reduce the roll hoop and reduce weight? Because what's the purpose of leaving that 4 inches?
You want to take
So we had a little bit of trouble with rule compliance. There's actually a rule of the main roll hoop bracing has to be a certain distance away from the top of the main roll hoop.
Right.
So we struggled with doing that and also the distance of the rear tangent of the helmet to those bracings as well in that line.
So if,
yeah.
yes, so
Okay.
if we were to reduce this, we would have issues accounting for
Yeah.
this clearance here.
Gotcha. The second one was about the heat treatment with chromoly. Why did you guys choose? Why was heat treatment a bad thing?
Well, it brought up a logistics issue, just due to the fact that all of the only tubes that needed to be heat treated were tubes that had really thick tabs on them that are outlined in the rule book, like the shoulder harness mounting bar, the engine mounts, things like that. And so those tubes would have to be taken separately, and just those tubes would have to be heat treated. And we don't want to heat treat the entire chassis. It also poses a risk. What if they normalize it for too long or too short? Then our whole chassis is a bust. There's also an increased cost of doing that heat treatment.
It says heat treat in the rule book.
I'm sorry?
It says heat treat in the rule book.
No. It doesn't say heat treat in the rule book.
Just based on material research, anything above 1/10 of an inch, they highly recommend
that you
treating.
heat treat the welds, yeah.
But where we were at in our timeline, TW actually went back on what materials they had, and they said that they didn't have the dimensions anymore for 4130.
Yeah.
And then also we were worried about the risk of, I'm sure y'all remember towards the end of, right before competition, like there are times that we have to weld things last minute or cut out things last minute depending on, yeah.
Yeah.
So if there was anything that we did need to add on to it,
Catch you up.
Okay.
Unless you want to finish that real quick.
I have one more question. Jigging.
Yeah.
Have you started designing?
yes.
Yes.
Yeah, we have. We already have one full version of the jig on a previous version, and we're creating the next version now. We only have to change a few planes.
Was it time?
Yeah, I wanted to open up for any questions from the audience. If Gavin doesn't have a question, we can keep going for 5 more minutes.
You can let them, do you have any questions?
Do you have any questions? Dr. Cameron or Dr.
The
Cameron?
only question I have is your list of in-kind sponsors. Is that the same people we had last year? Or is that list growing or diminishing?
TW helped us last year, and G&H helped us last year. All the other sponsors are new.
Art Specialties
Yeah.
helped us last
Yeah,
year.
Art Specialties helped us.
The top 3 are actually new. Yeah.
Art Specialties provides a lot more than just chassis, just benefiting chassis. They do a lot of machining for us. and
Raw
things.
materials.
Yeah.
So is there a good chance that they'll keep on next year?
Oh, absolutely.
Yeah.
Yeah. We went out and did a photo shoot with them and everything. So they're a good sponsor.
So I noticed that you guys were talking about reading up a test fixture to determine the torsional stiffness of the chassis. Have y'all considered using strain gauges measuring deflection on individual tubes?
Yeah.
Because as far as the loading scenarios that you guys mentioned earlier, if we had data from previous year's car from the suspension control arms using strain gauges, we could then calculate the loads applied directly to the bolts.
That's something we've considered, but based on its availability and cost, we're not sure if that's going to be feasible yet.
Yeah.
But
We're-
that's something we definitely need to consider.
We're still designing that experiment, so, but we're looking into it. John?
One of the things that the judges at the last year's competition pointed out specifically is the number of iterations of the chassis, and the number I've thrown out, I think it's about 30 or so. Where do we stand, including what we've done between the versions?
Halfway.
I believe we're about 15. We do need to make some minor changes in the tube bins, so we're about 16 versions of the chassis to go to competition with.
Well, we want to do more iterations after with more accurate data and see where we could maybe add in some light reinforcements. So that would add iterations to it as well, and it would give us more accurate data as far as what our differential forces are and what forces we're receiving from suspension.
16 iterations plus whatever you guys
Plus
did
whatever
last
we
year,
come for
because
the entire next semester.
you built that. You started with Eddie, right? We didn't start with Eddie. but-
No, we
no.
received suspension points really early, and we just did like a bare minimum basic local compliant chassis, and then built off of that as depending on what ones we received from the rest of the team.
All tubes are the same dimensions, the rule compliant dimensions, and we started narrowing down the dimensions of non-structural members and things like that.
So you did iterations moving the tube size down,
Yes.
Yeah.
seeing where you go.
Yeah.
Yes.
Why did you do round on the front suspension and square on the back?
We wanted to do square on the back, I could say, because square tubing performs better in bending. So that was the focus on the rear. Anthony, you want to talk about the front?
Okay. A reason for the round tubing in the front suspension, we realized that it was we had some difficulties trimming if these were square, and we also noticed if you can see here this open space, we wanted to make sure that we had a good weld here at that bend. Also, with our suspension jigging, the difference between the two the difficulty of jigging the suspension wasn't a major factor.
Yeah. And there won't be too much bending stress in the front suspension. I think it'll be a lot more torsion in the front and then a lot more bending in the rear due to the diff.
As far as manufacturing, it's going to be more difficult. Significantly more difficult with using around.
Yeah.
But we've discussed it before, I think. These are very bad. Is there a reason why you didn't use another tube? We can talk about this later, but you didn't between your, yeah.
Oh, here.
No. Are you talking about this?
Yeah.
Or no. Actually, that was in order to account for our steering,
Okay.
because now that our steering rack is not bottom mounted,
Yeah. Okay.
We wanted to have enough clearance for the tie bars,
Okay.
so that's what that is there. So that's why we left that open.
Have you done the front impact analysis and side impact and all that?
Only on the first version and randomly here and there, just to make sure that it's, something's not snapping.
I think it's beneficial.
But
Really?
what for our final versions and every version after that, we're gonna, I don't know the exact rule number, but for alternate frame rules, you know how it offers the 7 kilonewtons front, side impact, all of those, and we'll refine it based on those as well as the tire tag.
We have 15 seconds.
So I'm going to take more than 50-second answer. They asked me to ask mean questions. So you guys mentioned that you have simulations in both Abacus and SolidWorks, and you selected to use the SolidWorks version because it gave higher stresses and therefore more conservative. Is that a sufficient reason to choose one package over another? Why would there be differences between the two packages, and what can you do to minimize differences in the results?
Well, we didn't decide to choose SolidWorks for just what software we're going with. We just chose it to post it in the PowerPoint for now. That's a good question.
Also, we noticed that Abacus, the way that they arrange their meshes is slightly different from SolidWorks. So that would give slightly different results at the nodes.
What do you mean slightly different? What is slightly different?
Hexagonal mesh and versus rectangular for SolidWorks.
I mean,
What percentage
numbers,
difference are we
right.
talking about between the two packages? And is it reasonable?
Depends on the test. I mean, for our mini truss experiment, there were huge gaps. I'm trying to calculate something in my head real quick. For one of our torsion tests, we had about 12,000 and in Abacus for for bending stress, and then 13,000 psi for SolidWorks. So that's like 1,000 psi difference between the two.
More plenum. You said it was 3 times the size of the engine, right? So why not 6, 8, 10? Yeah, it's
Actually, the final version of my plenum is going to be about 6 times of the engine displacement. I'm trying to integrate that into the 8.0 version of the chassis. Hopefully it doesn't change so much this time, so it can stay this way.
What kind of throttle response are you losing with that 6 times? Is it noticeable, or is it small enough that it's not going to cause any difference in driving style?
Well, actually, I have not performed the CFD on the system yet because I haven't obtained the tension boundary conditions needed. So I do not have the answer for that as of now.
How are you going to make the plane? Are you buying it, or
I'm going to 3D print it.
What type of material?
I am thinking right now ABS, but actually I have done some research and the material for the plenum doesn't really, well, it does matter, but if you do epoxy coating and post-processing on it, you can achieve non-porous.
Do you have a process already in mind for that? I mean, that's what we tried last year, and we had
We're working
several iterations.
with Wayne Moss back
Yes.
then to
Okay.
go about what the post-processing would be for that.
Okay, this is Wayne.
MOSFET, yeah. They actually have a lab at what is it,
HCC.
HCC, and
Okay.
they have tons of about 30 3D machines.
Okay.
They can do powder printing.
He's very excited.
All different
Okay.
materials. Some are not
There's-
porous, like even carbon fiber.
He's excited to
Yeah, we
come
do
up with
have
solutions.
carbon fiber.
So did you consider doing engine modifications? Replacing your cams with different size cams?
We did, but once you open the engine, reliability goes down. I think that was our biggest point. We only have one engine, if that, at this point. So we were staying away from engine mods.
Do you have a plan for another engine?
Yes, we went to buy a new one and then rebuild this one, so we have a backup just in case.
the one in Eddie?
Yeah.
Yes.
What happened to that Husky one?
Mounting points are different, so we couldn't swap them right away. But yeah, I don't know if that one runs at this point.
The Husky made now.
That one would
We need a new wiring harness for the Husky, so
Yeah.
we don't know whether it runs or not. How
Yeah,
long
we're
it is.
not sure if it's working.
The ECU, you said the Mega Squirt 3, it's more programmable. It has a higher capability. What's the difference between that and the stock KTM?
So the stock KTM sensor, you can only really, there's only like 3 functions you can change. But with the Megasport, you actually can go ahead and expand a lot more. It even has data logging capabilities.
Okay.
So with this one, we're trying to change, like, timing, air to fuel ratios. We're trying to max out air to fuel ratio since we're using E85.
Okay.
We can actually reach other like more power from it, and so just have more capability from it in the sense that we can keep track of the injectors, the
Like when they fire, how they fire, how
when
So you
when
had
the
that
injectors fire.
capability,
Yeah,
not
we
just
had-
fuel injection, and we were able to log the capability was.
now we can adjust like when it fires, and
Excellent.
how,
Okay.
how much the valves overlap, how much.
Yeah.
Have you put all this stuff on Eddie to make sure it'll work?
Where,
So
that's
we
what
don't have
it
that
in
stuff
hand
yet.
yet.
So
Oh.
yeah,
Yeah.
we're working on
procurement
it.
is the hard part.
And you have the dyno, but you're dyno. So is that
Not the one
The
in the shop.
dyno in the
We have
shop.
the one at
MSR?
MSR.
Possibly.
Okay.
You're not gonna use the one they built last year?
The one in
It's not
It's in pieces. We try to get a non-capstone member, a couple of underclassmen to kind of fix it and work on it, but it's been slow going.
I think once they look at it, they get kind of scared.
Yeah.
It's everywhere in the shop.
Do you have someone working on the wire diagram for?
That and the power budget?
Yeah.
Yes.
So yes, I actually got an underclassman to start going around the teams to ask what are their electrical components, and so we can start keeping track of the power that we need to distribute to each part of the car.
Okay.
As far as wiring diagrams, that's what my going forward part of this presentation is going forward with that, because everybody's just finishing up, so that from now I can actually start doing this wiring diagram, and I hope to finish that by the end of the month.
Do you have a plan for mounting all your sensors? Because that was the big gripe from last year, because we just kind of had it rat nested. I mean,
Yeah,
it fits here.
We were thinking about a kind of a black box design, having everything kind of nice and neat,
Yeah.
and so that nothing's touching metal or.
We actually have some space here at the top. We've seen other teams do that. Maybe we can have a box covered, like to keep off from rain and stuff.
And you plan on having the gas tank under the
Underneath the
back?
seat, yeah. So I don't know if you saw under chassis presentation, they had a little like flat silver box looking thing. So it's gonna go in that area. The shape has changed, but it is gonna go underneath that incline of the firewall.
How big is it?
It's gonna be a 3.5 liter tank. Last year's was, I believe, 1.5 gallons, which comes out to be over 6 liters.
Yeah.
And that was way too much. What I was told in competition.
Kind of a two-part question involving operating environment. One part for Armando, one part for Cameron. Armando, how does the E85 behave in Lincoln, Nebraska under those climate conditions? And for Carmen, real quick, sorry. Traction limit varies significantly with surface type and tire temperature. So what parameters did you guys choose to decide to cut off first gear?
Well, we use optimum lap, where it gives you the best speed and gear that you should be in to get out of it. I think we used the tire data that provided. I'm not entirely sure that we used any data from suspension.
As far as selection of E85, in Lincoln, Nebraska is a lot drier climate, so we wouldn't have run into a problem of having the humidity being trapped in the fuel. Also, it is going to be pretty hot out there. E85 burns a lot cooler, so when it burns, it has a higher latent heat, which just means that it's going to suck up a lot of the thermal energy in the cylinder, which will also help cooling, so that they don't have to draw as much power with their fans and whatnot.
Do you remember what number you had for rolling resistance in optimum lap?
Don't remember, but I think it doesn't matter as long as you have enough power to get.
Well, I have a follow-up to that question. What factor of safety did you use in your axles?
Well, we haven't started our analysis.
Okay. Yeah, because your rolling resistance, more power, is always better. I'll come back to that. But the rolling resistance is going to affect your drive line and your axle selection a fair amount too, because then suddenly you have a negative force on the outside pushing backwards. So you want to talk about shear, you got one going this way, one going this way, you're just increasing it more and more. So I was wondering if you calculated rolling resistance on Lincoln's airfield ever.
No, yeah.
Sorry, go ahead.
Brandon.
How did you choose a gear ratio of 3?
We use Optimal Black, which is a program that gives you cornering speed, which is exactly what we wanted because we want to be fast out of the corners. And then we work backward from that.
Yeah, let's keep a question from the judges for now. Brandon,
Yeah, so this is, I mean, there was one person presenting about ECU, and I understand that you're in the selection process, you actually haven't got them in your hands.
Right.
So everybody, I mean, just kind of contribute your total knowledge on your power line research. As a future task, right? Hopefully as part of your tuning, you're going to have some kind of model or some idea of how it's going to respond. You actually want to go into its parameters. So how are you going to develop a systematic procedure to do your tuning reference data? So specifically, what are your major input variables that you want to track? What are your major output variables that you want to track? And how are you going to utilize your data logging capabilities to develop a reference set of data?
Okay, so as far as data logging goes, it pertains a lot to, at least for our team, it would be just engine temperatures. Make sure that we're getting, we're not heating up at idle, overheating, which is one of the biggest problems we had last year. And so that will be, as far as data logging, one of the things we're going to be looking at the most.
Another thing is we also have, suspension wants to know, their kind of, how far they're moving, what kind of forces they're seeing. MMI has a lot that they want to know. As far as throttle position, steering angle, we can log a lot of that. With the different sensors, we can connect to this.
Also for intake, we need to know the valve timing. We can tune that. We can check the mass flow rate with the sensors. Also the injectors, we're gonna maximize that flow rate to get actual right fuel efficient.
So actually with for tuning, I have this little fuel chart here. It shows the stoichiometric like AFR readings for E85, and then the safe AFRs for if you want to run rich or you want to run lean. And this is important because since the E85 produces more, has less energy content. We need about 30% more burning of the fuel, which means we're gonna have a lower fuel efficiency. But in our endurance test, which is where our fuel efficiency is going to be tested, we're going to plan to run lean to use less fuel and therefore conserve as much fuel as possible. And so the way to do it when tuning goes, we're going to go slowly from stoichiometric to the numbers listed here, and just see, rate the temperatures, mass airflow, make sure that we're getting the right amount of air in there, and the injection timing as well for fuel. And then we're just gonna go slowly and make sure that we're running into, we're not gonna, burn a hole through the engine or something like that.
We have like 3.5 minutes. If anybody in the audience wants to say a question. Or not, I have a question. When you're talking about the black radiators, have you devised any tests or anything that you're going to do for validation?
Yeah, so tomorrow when we're doing that test, we're going to have mass flow and then we're going to do inlet and outlet temperature. So we'll have our pre-data, and then once we get our radiators in, before we get our new radiators in, I have watched some videos where they did it. You've seen the video too, we were in the same class. They did all the experiment in front of us in that video, and so I want to get numbers with a fan, and maybe we'll put an epoxy on it that can be removed. I haven't looked that far into it, but once we get those in hand, we'll move forward with that.
Follow that up.
Yeah.
Fully realizing that you still need to do some testing on that. First, why not both radiators black? And second, what's the expected temperature of the inside surface of the side pod, and what color will the inside surface of the side pod be?
Sorry, can you repeat the first part of that question?
Why not both black?
Okay, so both black. When you are at idle, we're gonna have one fan on one side and the other one will be painted black. So when you're at idle, you have no air coming through it unless you have a fan. So to reduce weight, we're gonna have one fan and then on the other one painted black, so heat can be dissipated through that one because it is painted black. And so if you had two fans, we wouldn't have to paint it. But for lightweight, we're gonna go with one fan on one side.
And given that that heat transfer is kind of the sum total of the surroundings and the object itself, what about the inside of the side pod?
Inside the side pod, hopefully black so we can dissipate the heat. We're gonna get with Aero to do that. Inside temperature is hopefully ambient. I don't think the heat will dissipate that far. It might be a little hot, but at the bottom of the side pod, we should be close to air inlet or water inlet temperatures.
Good question.
Yeah, you had an engine torque chart somewhere? It's like an Excel looking chart. I think it's toward the end, actually.
Oh yeah. I had a torque chart. It wasn't this one?
I think that's it.
Okay.
Where did it come from? Because it looks like something that you guys plotted yourself, or
Yeah, it was found online with
and how did you get it?
found online. It was a KTM. It was a 450, a YZF 450, a Yamaha engine, and it was just an experiment run. They had all the information that they did. We do need to validate this, but it was good to have a baseline.
Okay. So you do plan to validate?
Yes.
This is just somebody ran an experiment. Did they describe their methodology?
Yes, they did. They used a dyno, and then they had the water temperatures at each torque, or water temperature, and then ran the dyno to get their torque, and they did it 4 times.
With the two different radiators having different types of cooling, I'm assuming that you are going to have different amounts of cooling on different sides. So how are you working with that? Why you have 2 outlets, right, in one inlet? So with the path of least resistance, is that how that water is working?
There's 2 ways you can run radiators, parallel or series. If you run in parallel, you have to make sure the resistance is equal for both radiators. That is just have equal length of tubing. The different colors is not going to vary. The temperature will be slightly different, but not enough to vary the flow. And then was there a second part?
Yeah, I'm just looking to see how much you know.
Yeah, and so series, if that comes in problem, we'll just run one hose, connect them in series. Okay. It'll be less effective, but it'll still work and will not overheat.
Also, this is mainly just for idle. At speed,
Yeah.
they're going to be the same temperature. We're going to push them through pretty
I'm gonna cut you guys off. Let's end time. Carmen, get your charger.
Do anything with rolling resistance? As far as calculating that, okay. One of the big problems we had last year, and this is driveline too. One of the big problems we had was we got to Lincoln and the airfield was very coarse grit, and we were like bogging our engine just under normal operation, straight line normal operation. So you might want to take that into account when you're considering your forces, your FEA, and for driveline and power too. It was nuts how much that difference made. Okay. Okay. I just wanted to point that out because it's not the same. You can go to MSR and slip around and go to Lincoln, Nebraska on an airfield designed for F-16s to land on and have completely different characteristics. But that's actually on the design sheet that the judges get. They know about it.
How do you plan on finding the force distribution from the control arms to the chassis?
So the first thing is we have a book that we're looking through, race car design, and it pretty much goes through processes of doing that using hand calculations. Currently working on it. They get a bit complicated, and the other thing we were trying to do is we were really spending a lot of time trying to implement FEA with SolidWorks and with Abacus, but we've been running into a lot of issues with it, just with all the moving parts and everything. So I'm considering maybe doing a solid truss and just seeing if we can get some data from that.
Yeah, Jeremiah recommended a 5-bar truss system. Specifically, it was the ball joints that were a real pain in finding forces going through control arms. So we have to find a way to simplify it.
Okay.
Probably just one piece of
Are you guys working with Brian Lane?
We were about to contact him. We have some members that actually work with Brian Lane, who we've been consulting with.
You haven't?
We haven't met with him directly this semester now.
I would say you should do that.
Okay.
As soon as possible.
Especially on your
Gotcha.
uprights.
Yeah.
Okay.
Like 2 months ago.
What's your ride height this year?
So ride height at the chassis is 1.6 inches, but we're going to have a diffuser, so our ride height will actually be about 1.1 inches, the lowest point of the chassis. The nose of the chassis is actually going to be lifted up a little bit, so the lowest part will be right under the driver.
So
So last year, the tuning for the suspension pretty much came down to counting threads on the control arms and whatnot. Is there a way that you guys have in mind to set a benchmark value and improve upon that system to make it, if we get to Lincoln and the conditions are different, or we're testing here, the conditions are different, that we can easily swap back between the two, or 3 or 4, however many?
So we use Optimum Kinematics and Optimum Dynamics for small adjustments on control arms. For example, we can widen the track width a little bit, we can widen the wheelbase slightly, and we can make jigs for control arms. We can actually plug in points, Optimum K and Optimum D, see what our results are, and make applicable changes on the control arms using that.
Well, I think what you were asking last year when we wanted to increase any of the dimensions at all, we counted and said there are 6 threads showing after this nut. Okay, put a piece of tape on, now lift it up, screw it in, exactly 2 more threads now are showing, put it back down, test it. How did that work? And it was just a bad system. Like, it was hard to read, and if you look down here, it's 5 threads. If you look up here, there's 6 threads, and you guys have I don't know if you've thought about that or.
So you're trying to say like a method of alignment, of like maybe some sort of like machine that'll kind of tell us alignment quickly, or
That more so like setting benchmarks. Like this is our standard suspension tuning, and then we know we can have this setup so we can move between different setups that we have known reactions to or known changes.
I see what you're saying.
Yeah. So one thing they did last year is they used shims on uprights, and I know that was a reliable way of accounting for adjustments that were made. Each shim equals this much degree of camber, this much degree of toe. They get alignment. So if we go to MSR and we shim it to a certain camber, we get an alignment. We can re-shim it to another setting, get an alignment. So we know that whenever we add those shims, we're going to have this suspension set up specifically, and we can record that and document that.
You guys, sorry, go ahead, I've asked a lot.
When you're talking about control arms, you mentioned you performed a basic force analysis. Explain what your basic force analysis means.
So what that really was it came from the race car dynamics book. It showed us a formula of how force should basically distribute through the upper and lower control arms. And I used that and then computed the stress within the control arms and shear forces and whatnot. Just kind of simple stuff, to be honest with you. But the reason for that was just the numbers that I was getting were way below the strength of our material. Our materials were just seemed to be stronger than the forces I got from a large factory.
I have a follow-up question on that. You said that you guys used a factor of safety of 3. How did you get to a number of 3, and what sources of variability would you expect that you have to have a factor of safety for?
I believe that was misspoken. Yeah. Factor of safety is 1.3.
Yeah, it was from the book again, Race Car Dynamics. They recommended a factor of safety of 1.3 is where we got that from.
Okay.
And what was the
second part is why? What accounts for the 0.3 that you would expect?
It's a recommendation between 1.3 and 1.5 that Millikan recommends, that it's recommended in race car design. Claude Burrell, all these big name FSAE members recommend this.
Okay.
And most of them settle on 1.3. What we're doing, we're also designing for the maximum lateral force as well, over 1.8 Gs, slightly over 1.8 Gs, and then multiplying that by a safety factor of 1.3. So we're hitting somewhere in excess of 2 Gs that we do not expect to realistically see. 2 Gs possibly at the maximum, closer to 1.8.
Well, the question is, where would the excess or where would the variability come from? What sources?
Well, the biggest thing I could think of though, that sources of variability like this are going to be like impacts. If say like you hit a cone or something with a wheel, that would definitely cause a spike of just from the extra force of hitting the cone, and like surfaces that aren't completely flat, some things like that. I think might be what you're talking about.
That's yeah.
Yeah, there's other things like that.
Do we have time for more?
We have like 3 more minutes to judge questions, or
Right.
5 minutes.
Sure. So you are proposing that you're eventually going to do FEA analysis on your cats. Explain your methodology, specifically what boundary conditions you are going to use. Are you doing static versus dynamic loads, and how will you account for transient loads? And of course, boundary conditions are the most important thing in FEA, so make sure you think that part through carefully.
To be completely honest with you, I haven't been doing a lot of the work with the FEA myself.
we've actually had some. Okay, so for example, on the uprights, the ball joint on the bottom housing is constrained by the damper in the X, Y, and Z direction. The top ball joint is constrained in the longitudinal and the lateral direction, but not in the vertical direction. So those are constraints on there. The brake mounting can't move from its position. So there's forces applied from braking on the mounts. I don't know if you should. Back. So over here. And there's also the constraint of the steering rod over here. So we're still doing analysis with forces. We applied the max cornering forces here and max braking here. I don't know if doing it at the same time would help. We're still, going through the analysis. Yeah, those are the constraints on the upright itself.
Okay.
Who's doing the analysis? Are you?
Yeah, I'm working with a guy. He's really Quinn. He's not here right now, but he's a master student. He's good at SolidWorks. So yeah.
So follow-up question. So you have you said some things are constraints. So pick any one of the ones you just mentioned. How would you model those constraints in one? Just mathematically, you say you use this type of boundary condition. Why?
What do you mean? How would model?
So modeling means that eventually in your simulation you have to make it a math equation. So how would you turn your understanding of how that thing is constrained to some sort of math equation in one?
I honestly do not know yet. I'm still working.
So that's just, again, something that
right.
we expected to be able to answer.
Yeah.
We can open up for audience questions. Also, just make a note. Thank you for being here, Dr. Chen.
You guys chose to use deep groove ball bearings. Why did you choose that over tapered roller bearings?
Well, tapered roller bearings would require tube itself to help balance the forces. Plus, we're not expecting too much axial force, and the deep groove can actually hold some axial force. Plus, we have a lock nut to retain it in case failure happens.
So are you all concerned about like backlash because it's not preloaded?
No, not really. We're going to have a press fit of about, I think it was 66 micronewtons was recommended by the bearing catalog. So, and their steel housing we don't expect thermal expansion in there, so we feel pretty safe with that.
When you were performing your FEA on the uprights, how many different designs or different versions did you go through before you picked your final design?
So this isn't the final design, we're still running it. In the stress concentrated areas, which are the least, we're going to reduce not the area, I guess the length, or by 2 millimeters. That was we read a paper that kind of did its iterations by that. So yeah.
What material are the uprights?
4340 steel.
4340.
Yeah.
Is ARC Specialties doing this for you guys again?
Say that again.
Is ARC Specialties going to build them again?
Hopefully.
We plan on using ARC Specialties. We know that they're a sponsor and that we can rely on them for this.
Right.
Make sure you have an open communication with them on your time constraints.
Yeah.
Okay.
So we had a lot of issues last year with running to. We had the whole car built, but we were waiting on the uprights.
Right.
Okay.
Are you talking to them now?
I remember that, actually.
I believe Brandon's in touch with them.
Yeah, we're trying to have a single point of contact for all of our sponsors.
Do you guys have numbers on friction across the whole system? I don't know where to start, I guess, but friction was a big point in Gladys's year, I know for sure. They asked, what's your friction here? What's your friction here? What's your friction here? I don't want us to take the time to go through all of them, but do you guys have a pretty good understanding of friction on your ball bearings, all the friction between the wheels and the hubs, friction on everything?
Gotcha.
Your dampers slide in and out. They wanted to know all of that. I wonder if you guys have done anything along those lines.
No, we don't. Aside from tire coefficients of friction, we need to work on that.
I don't think they were looking too much in depth. They were just looking to see if you guys understood that, if it was accounted for with powertrains.
Right.
Like
Just going down rabbit holes.
goals of power and stuff like that. Yeah.
Okay.
Do you know if you have to heat treat these uprights?
We're looking at that. We're not sure yet. I mean, it would help with the stiffness, and especially reducing compliance.
have y'all taken that like into account in your timeline, and whether if something does need to be welded last minute, how that heat treatment will affect the process during manufacturing?
So we're expecting to get everything ordered by January, early January. So our timeline was March 1st. I believe we wanted everything manufactured, everything assembled by April 27th. So yeah, that's a pretty good margin also.
Who's responsible for suspension? Suspension points, sorry.
Points?
Yeah.
I think David.
But you guys are making the points. Who's responsible for the tabs?
The tabs, we will be responsible for tabs.
You're working with chassis with that?
We are. We're discussing it, and once we trace the forces through the control arms through our FEA, we're going to be able to analyze those tabs. We know the tabs from last year held up great. They were lightweight. I don't see anything wrong with using it. We still need to do calculations on them before we, validate using those.
Have you guys worked with chassis to see the load into the chassis from the dampers, springs, all that?
So I'm still working on calculations as far as like the load being transferred from the push rod through the belt crank and into the chassis, damper and chassis. I have preliminary estimates of about, just for a weight transfer, of about 400 newtons, I think, at the front and 360 newtons at the rear through this. That's a load at 2 Gs being transferred through the dampers.
So
through springs.
when is the chassis finalized?
Did you just ask when it's finalized?
When's it supposed to be finalized?
It is finalized currently for version 8.0. The SES was submitted. So
But he hasn't given you
yeah,
analysis.
that's something that we're gonna have to
We're
put
still-
in reinforcements.
Yeah, we had challenges with the rear dampers, finding the right placement for the dampers. Initially, we thought about a setup where we would have the dampers in front, above and in front of the differential, but that didn't work out. And now we're working on an alternate plan where we're going to place the dampers behind the differential. Now, the belt cranks are going to be mounted on the side members, and we're going to have the dampers come down, angle down towards the middle, the rear, and that setup is actually going to allow us to reduce the push rod length. Again, the force calculations are still in progress. I've calculated all the other parameters such as spring stiffnesses, damping forces, roll coefficients, roll gradients. So we have all those preliminary numbers. It's just now I'm gonna mainly working on belt crank geometry to get the motion ratios, which is one of the most challenging things for suspension. I know last year we had issues with placement of the rear dampers. They would have to be placed way at the back, and that was not an ideal location for dampers. The belt crank had to be. We had a lot of challenges because of that. And having the dampers placed all the way at the back, it's also not recommended because you're concentrating more mass behind the wheelbase, which affects the polar moment of inertia of the car. So ideally, we wanted to have those dampers more towards the middle. But packaging has been a challenge. I'm working with chassis to resolve this issue and hopefully just get that belt crank geometry right so that we can get those linear motion ratios, which is one of the most important things now for the damping system.
When is the chassis being cut?
We haven't dropped the tubing off yet, but we are going to send Brian on the model on Monday so he can check all of our weldments.
Alright, we're good for the 15 minutes of questions for that. Thank you guys so much.
Thanks.
Let's take a.
Would you like for a picture?
One more.
91.
There you go.
So how are you mounting those rails to the chassis?
Those rails will be mounted by tabs in each of those pinholes. So 8 tabs total. On the back, they'll be mounted directly to the bulkhead, and on the front, they'll be mounted on the same chassis member that the steering rack is mounted on.
How long are those rails?
Those rails, 14 inches, about 13 inches long.
Are you using? You said you're aluminum 6061?
Yes.
How thick?
That aluminum, the rails themselves, those are about 3/16 inches thick.
The reason I'm asking is because I know ours last year, it was pretty hefty duty, but when you started stomping on that thing was rocking and rolling, and it was moving a lot. So I'm just concerned that this may move even more because it's aluminum. I don't know. We should do a lot of analysis on that.
So yeah, I did do some analysis on it. If you go back past our everything, a little more, another one, a little more, no, keep going. There you go. All right, so I did run a little bit of an analysis on there. I didn't put deflection on here. I just did want to show like the safety factor we ended up with. I applied about 53 psi load, which is approximately 450 pounds of load onto the brake pedal, and that gave me, and that's like, you know, if you remember from the rules, the brake pedal has to take 2,000 newtons expected, right? So at that approximate weight, I got a safety factor about 1.05, which is down at the actual rails, but that's like an extremely excessive load. And it's not, you don't expect to see that at competition because when they actually test that, all they do is have the judges just step on the pedal and push as hard as they can.
And they're stomping.
They're stomping.
Yeah.
They're stomping. And you can expect to see. I think the deflection that I got, I can't remember the number exactly, but it was about 0.05 inches maximum, I think, anywhere in the actual design. So it wasn't. I didn't see any huge deflections. Seeing as that y'all saw like a lot of movement last year, I may have to bulk something up, but there's room to do that. It's already extremely lightweight design, and if I have to bulk it up, then I don't think it'll be too big of a problem.
Have you fitted in the chassis? You put it in the chassis. And
Yes.
mounting's good.
Yeah, so one of the things I do want to do is send out like that railing to get machined as quickly as possible, because I know last year y'all had trouble placing the base plate in there because it was machined a little late in comparison to when y'all were setting the chassis up. So one of the things that I'd like to get done is actually get those railing pieces done as soon as possible, so that while chassis is building, they can put them in there while they're welding and have it ready.
I think our problem was we had it built and then we put the chassis together and it wasn't perfect, and so we had to shave.
Yeah. So if that's the case, then yeah, having that at the same time and then being able to like weld around and fit those pieces in together, I think that'd be really beneficial. So.
I don't remember the rules really well, but I wasn't sure if you can actually weld anything to the bulkhead.
So the rule states we have to be an inch from the impact attenuator plate.
Okay.
So yeah, last year we had an extra inch in there
Yeah.
because we read the rule differently, and that's why the base plate was an inch away from the bulkhead.
Okay. I just wasn't sure if you were actually allowed to weld onto the.
I haven't read any rule about that.
Okay.
No, Erica?
Yeah, I'm not. I
A good inquiry.
Yeah.
Yeah, you did.
Andrew had a question.
Yeah, with that 2,000, if you take 2,000 and just keep going up until something breaks, do you know what's going to break first?
I'd assume the rail.
Okay.
Yeah.
Well, that would be something good to know, because word for word from a paper I read online, it said never underestimate the strength of a driver under adrenaline.
Yeah, I've seen
If you're
it.
crashing, your adrenaline's going nuts, and you can just right
Yeah.
through that. So if that pin shears first, then you're not going to be able to hit the cutoff switch on the back. And if your master cylinders break, stuff like that. So you might want to at least have an answer for that.
Yeah,
especially
have it
with
in mind.
inspection and stuff like that. They probably wouldn't ask it. But
Yeah, I've even read things that say to design everything up to like 600 pounds of force, like
Yeah.
But that just seems excessive to me. So I
It is
decided.
excessive under all operations
Yeah.
that we will likely see. But if you're headed for a wall and your driver is
Essentially,
strong,
what I assumed is that if you the rules there saying 2,000 like newtons of force, that's like a built-in safety factor that the rules build in themselves. So I figured if I designed right up to that and I'm right on that safety factor, then following that, it's a safe bet that the whole thing will be fine.
Kind of piggybacking on that driver adrenaline point, the steering wheel, what kind of force analysis did you do on that, and did you compare, because even when 3D printing ABS, you have different ways that you could lay it out. How much have you explored there?
Well, I haven't really explored in terms of the laying out of this ABS, but I did an estimate of 330 newtons on each side. That's pretending to be the hands from driver input, and it came out pretty sound. As you can see, the safety factor. I mean, I'm even wasting material.
Is that pushing, pulling? Do you do any of the corners or something?
Well, yeah. So we used a little bit of suspension, gave us an estimate on the lock-to-lock degree. We used that, and we also did with a torque as well. And it's still preliminary, but it was still a little bit of the pressure that we're putting on it. So.
You said 350 newtons?
No, 330 newtons on each side.
So you said the middle part will be metal and then ABS aluminum?
Yeah.
Okay. How do you plan on
attaching those two? I'm still working on that.
Okay.
Yeah.
What was the decision made to make one
versus buy one?
Right.
Yes. So essentially, when we buy one, I did a design matrix, and when we buy one, is if you go higher than that 7 inches that y'all did last year, it turns out to be above $300. Because the steering wheel, if you want it at 9 inches, which is essentially what we want, so if you go bigger, then you have the steering wheel in between your legs. So we measured and we noticed that at 9 inches will be a perfect diameter, and the driver's input was great. So counting those factors and weight, it turned out to be better to manufacture.
And we measured it based on the mock-up cockpit. So we were able to put like a large driver in there and then make sure the steering wheel didn't interfere with his legs, and a smaller driver too.
Yeah. I mean, $300 sounds like a lot, but that's pretty important. If you can't steer, you can't do anything. Right? I don't know. I hope it works.
Dr. Chang.
Me too.
So just a question there. So my understanding is that like 3-prong piece in the middle is the aluminum,
Yeah.
and then
Yes. And then the outside is the ABS.
Okay.
Plastic.
How are you modeling the material properties, specifically the isotropy of your 3D print?
We used the software's already like set up, kind of like the default material. So I don't really know what it is.
So did you understand mostly?
I think so.
Okay.
I think so.
Yeah, that's where the layout, the
Oh.
printed.
I think we use just default. I mean, it's preliminary, so I think it's default. But I'll look into that. I'll come on to you about it.
Do you have a plan B?
Buy it. Yeah.
Should look at that.
So you said for the rotors, there's 2 different sizes. For the front, it's a 7.5. For the rear, it's 6.5.
Yes.
Why?
Because I try to reduce the weight as much as possible, and based on the weight distribution of the car from suspension, most of the force is going to apply onto the front more. So the GB200 with the larger brake pads, that required the larger area of touching the rotor. But for the CP4226, the pad is a little bit smaller, so I'll be able to reduce the size of the rotor a little bit. So I hope that reduces the size.
So
Because
you're using 2 different pads, front and rear?
yes,
Okay.
the same design, but 2 different sizes.
Okay.
Yes.
And then, then you're using 2 different calipers, right?
Yes.
Okay. Could you go back one more slide? Or where, I guess, this decision of your calipers, how you chose them?
Yes, calipers go to the
Okay.
back.
So I just misunderstood, I guess. Can you go back to them?
Yes.
So you're going with those 2 in red?
Yes.
Okay.
GB200 like last year is quite bigger than and stronger than the CP4226. I gotta put in the front because it's mostly the force gonna rely on the front when you brake, and 4226 save weight and save material. I put it in the back, but still works fine. When I did a calculation, is match the line pressure and the pressure in the braking line.
Okay.
Yeah, essentially, the goal is just put as much braking force in the front,
In the front.
because that's where the like weight is transferred to the front, and that's where all the load is taken. And since the CP4226 has like a much smaller piston area, it's not going to apply as much force to the rear. So the goal is to find something smaller that could go in the back.
Okay. We've got about 4 minutes for questions from the audience.
I know there's going to be a lot of vibrations when you're driving. How are you going to ensure that the pedal box does not shift to a different position with all this? What kind of device do you have to sort of lock it on those rails?
Well, it's just if you go to the pedal box, there's just going to be 3 bolts. There's the one behind the gas pedal, there's one right in front of the brake pedal, and there's one between the master cylinders back there. And those 3 bolts are going to hold it in place.
So you're using just regular threaded bolts?
Just regular threaded grade 5 bolts. Which are rated for like 90,000 psi yield strength or something like that, which can take basically like all the load.
Okay. I would just
maybe
look at
that's
that
what I read it.
more with the
Am I
vibrations
wrong?
of the kind of just coming off the bolt.
Wait, say that again?
I would just look a little bit more on that because just in actual in life, nuts just vibrate right off of the bolt.
Yeah.
So maybe look at
So maybe it's like lock nuts or something like that.
that.
Yeah, Loctite, lock nuts.
So
Well,
maybe
you want it to be
backwards
adjustable though.
Yeah.
So maybe not Loctite, but maybe like
Maybe some
lock
kind of
nut bolts.
mechanical device, engine or something.
Yeah.
How are you planning on moving those on the rear between the master cylinders? Have you measured that space? If you can actually get a wrench in?
Yes.
Oh, yes, I
Yeah.
did.
Okay.
Yeah, I made sure that you could fit every bolt and actually reach it.
And so also, are you gonna have a floor?
There is a floor pin that will be easily removable, thanks to John.
Okay.
So you'll be able to get under the car and actually undo that bolt. Yes.
So I was just going to expand on what you guys were talking about. There's a type of bolt that's manufactured by Stage 8. They have a little C-clip groove that goes on the top of them.
Sean, can you leave expanding for after the presentations?
I was just saying, you had your safety factor for the rails for your brake pedals for 1.05. Have you did any fatigue analysis on it?
I've done no fatigue analysis.
Okay, because 316 aluminum is pretty thin. I feel like it's really thin after that kind of small safety factor. I feel like you might end up bending it or breaking it after all the testing you might do.
That safety factor is it's to 450 pounds of applied load to the brake pedal, which is 2,000 newtons, which I really think that when they put that in the rules, it's to say, okay, here's a built-in safety factor so you don't destroy your brakes. And so, I mean, there's also room to bulk it up a little bit. I'll probably consider that because that is close to really way too close to 1. So I may change that, may bulk it up a little bit. This design isn't completely final yet. So.
But that's all aluminum.
For the most part, yes.
Yeah. I'm just saying, if you're gonna bulk it up when you're building it and
Yeah.
installing it, it's gonna be really tough. I hope it works. I really do. But I think it's gonna have to be bulked up a lot.
Say again?
It's gonna have to be bulked up a lot.
Okay. Where specifically do you think?
The mounting.
The mounting?
Yeah. I think ours was pretty robust, and we had to bulk up the tabs.
The tab?
Because it was deflecting a lot. But.
Okay, well, but the tabs are still going to be just regular steel tabs.
But you're just using pins, right?
Well, I was going to put bolts through those tabs.
I thought you were mounting to the pins.
Where is it? I'm saying if we're mounting to the chassis, I'm going to put tabs here, run bolts through them, just connect it that way.
And it's like that on this side?
Yeah, on both sides, at 4 points.
4 points.
I guess I'll have to see it. Yeah, we'll see.
John.
Min, you had 3 different basic rotor designs in the beginning, and you chose the drilled as opposed to the grooved and drilled and the blank, right? Yes. Did you do anything after that point to optimize that design?
Right now, I'm still working with the suspension to change the size in size because of the hub, the mounting with the hub. So probably by changing that, the thermal analysis is going to change a little bit, and the FEA when we do actual mounting with the hub, that might change a little bit. So that might change the thickness if I want it more bulky, so it can resist more force. That thing for now.
Okay, so the weight is still not quite nailed down and all that?
No, I don't think so.
That's all the time we have. So.
Sorry, one more. Is that a floating rotor design?
How
are you mounting it?
Mounting on the it's going to be toward the driver. I mean, the rotor or the caliper.
Yeah, floating rotor, right?
Oh, floating rotor, yeah, floating. I mean, confused.
I'm just worried.
The undertray. So where the undertray and the diffuser. So we just want to make sure that will hold up for the. Yes.
Do you guys have plans for destructive testing on those?
Yes.
Oh, okay.
That's part of the reason why the samples were all standardized.
Yeah.
Number one, the big thing that we're considering here is the area to weight ratio. Because the thickness of a material can vary depending on the strength requirements. We're standardizing this by saying we can cover this much of an opening essentially. Then we're going to compare that with the impact testing. We're going to do drop testing. So there'll be a couple things. We'll do a step test, number one, to see if the driver can stand on it and get in and out. Then there'll also be a drop test in case we drop a wrench or an impact wrench or something on it to make sure that we don't destroy it.
So
Yes.
when you guys are doing your CFD, probably half or 3/4 of the amount of time that you really want downforce is when you're turning, right? So have your CFD calculations had air coming straight on, or is the air coming at an angle? Or I don't know if you guys have considered that.
Are you asking, did we take in consideration for cross flow?
Yeah.
While turning on our...
Like what's the velocity of your air when it's in your CFD?
Well, when we ran the analysis for the basic flow design in Autodesk Flow, we didn't take in consideration of the cross flow. It was just for validation purposes for our design versions that we're going to be going through. Furthermore, throughout the rest of this remainder of the winter break and at the beginning of the next semester, we can actually begin our final design iterations now that Chassis has finally finished their final design. Only then now we can actually produce this information for a future meeting. I'll be able to provide that information at a later time. Thank you.
The model that we have set up right now for the, can I steal the thing? The model that we've got set up right now is set up, I can show you on this. We're including the wheels, an approximation of the suspension tie rods. All that stuff is set up parametrically, so I can go in and vary the angle of attack on the wheels so that we can include that as well, because you go from having a symmetrical CFD model to something that's going to give you different results based on the positioning of the wheels. So we've included the option of changing that as well.
So for the side pod entrances, if we could get a front view, please. Yeah, the entrance looks like it's a little bit closed off by that vertical plane. Does that have to do with the flow around the tires, the flow coming from under the nose, or is that yet to be addressed?
Which area specifically are you targeting?
The
Right
white
here?
surface that looks like it's vertical, kind of closing off some of that potential.
So that area, it's a frontal projection of it. The area is actually fairly large, and what we have to take into account here is that a good portion of this is shrouded by the tires anyways. What we've seen from observing the flow lines is that the air does seem to channel through there and follow that naturally, so it doesn't look to be impeding flow. We're going to validate that now that Spencer's selected the radiators that we're going to use, and we can do the porous medium calculation to determine the actual throughput for the side pods.
So the decision has been made to use side pod.
What we saw in our analysis, because I didn't include this here, but we did run some very, and I want to emphasize, the analysis that we've been doing so far is very, very basic. But it's enough of a justification, and we've compared it to other simulation software. The numbers match up as far as drag and the streamlines are concerned. That when we compared the drag without side pods to the drag with side pods, we actually got a lower value, and it seems like there's a lot less turbulence created in front of the rear wheels, and that seems to be contributing to that. The estimate that if I'm remembering correctly, was approximately 40 newtons at 20 meters per second.
Is there also something about heat spill around the radiators?
Yes, sir.
So you're using the side pods, you're sort of capturing some pretty high velocity air. Are you planning on using that air to cool any other parts down, or are you directing that air anywhere, or are you just going to house the radiator?
At the moment, we are currently using the side pods to cool specifically for the radiator. We have taken in consideration to investigate these further channels to redirect that air from the side pods. Again, right now we're just focusing on just the basic scope of one component at a time, so that way we can actually generate better information and it wouldn't be so crude, or for in any instance that we might not impede our analysis. Yes, sir.
So one of the big things you kind of touched on was getting out of the car and
The driver egress?
Yeah.
Yes, sir.
I know you said you plan on doing a step test. Well, what kind of safety factor do you plan on putting into that? Because if the driver's leg goes through that, it obviously goes through the radiator, and a lot of heavy injury can be had. So what kind of safety are you going to ensure on that?
The radiator position that we're working with right now is behind the main roll hoop. So as far as stepping through the radiator is concerned, it's not a major issue, unless they decide that they're going to, do a fireman swing around the roll hoop. I can tell you that if I'm getting out of the car, I'm not taking the time to do that. As far as the step test goes, the driver on adrenaline that was used earlier is a very good explanation. If you're jumping, you're not thinking about, oh no, I have to get over the side pod. That being said, the area occupied by the pods is relatively small. And so while it is a concern, we haven't finalized our testing procedure for that yet.
Any more questions?
What kind of, how are you mounting your devices to the car specifically? Like, are you using quarter-turn fasteners? Screws, bolts?
So we're studying that as well. I have seen previous designs from other universities, and they've used bolts as well as quarter-turn fasteners, especially for the nose cone. For the nose cone, they do it like that, and then the side pods, of course, they're going to have the side bar right here railing to kind of add support to it. That is, of course, still under investigation. As of right now, we're looking at bolts and quarter-turn fasteners, and hopefully reaching out to THC Connections Fasteners Company to hopefully get those parts and materials gotten to us.
Are you guys familiar with the fasteners that we already have available in the shop?
I've seen previous years E-bombs, and I saw that they were donated and with the quantity of it. I'm just not sure as far as who else is using the fasteners and all the quantity that'll be used this year. I'll look into it.
In an effort to minimize weight too, for a lot of the non-critical components, we're looking at using rib nuts, so that rather than having an entire nut attached to there, which the weight is fairly insignificant for an individual nut, but it does add up when you have 20 of them across the length of the component. So we're looking into saving weight that way as well.
Buchanan, you had a question?
Yeah, as these three will tell you, we've taken the nose cone off last year. How many times? A lot of times. Off on, off on, off on. Unsure as well. Have you guys thought about removing it and ease of taking that off and putting it back on multiple times to access different?
That's also part of this process. We because we thought about making it as a whole or in sections. Yeah. So we're going more with sections because we know that you will need to work on maybe last minute adjustments on the chassis or something. So that's why they're highlighted separately, because we've thought about that, and we think, okay, sectioning these parts and then bringing them all together would make for easier working on the car.
Did y'all do any analysis on lift? I heard drag and downforce, but did y'all do any on lift?
No, I wasn't able to go through the information thoroughly to actually be able to come up with the actual lift portions. I'm sorry, but we'll be able to provide that information at a later time.
So the flow design software, again, it's very, very preliminary. It's good for giving you drag data and streamlines. And we've compared this with the simulations run in a wind tunnel that I created in SolidWorks, and the numbers do seem to mesh. The value that it gives you, though, it does not calculate lift. Because you can vary everything in real time, the dimensions of the wind tunnel and the wind speed, it doesn't calculate lift. It's just not an option in the software. But that's our kind of next hit list now that we've gotten the bodywork design stabilized.
Just so you had a question for the side pods. Are you working? How are you working together with like the power team? I guess whoever's choosing. What are they telling you? Kind of how they want their flow going through the radiator, and how you're designing the pods to do it. Are you increasing the speed, or are you increasing the area to get like a bigger pressure difference going through the radiator to allow more flow going through the radiator?
Right. Yes, we do have. Luckily, we do have integrations meetings on Monday, so we are always in contact with Spencer and the rest of his team. We have been communicating on their ideas that they had on certain angles for the radiator, so that we can actually optimize the airflow. So yes, we do keep in contact with them on how we would want to maximize these things or further optimize these values. So yeah.
What do you have modeled? Like, what is your expectation for what the inside of the side pod looks like?
I'm sorry?
So what does the inside of the side pod look like, basically, like from a diameter perspective, from a flow perspective?
So currently they're just modeled as shells, because all that at this point we're concerned about is getting, number one, was stabilizing the design of the bodywork, so that we didn't have sort of big swings between versions. Now that we have that built, we're working on finalizing the channels for the diffuser, because if you look at the picture on version 6, there's no ramp right here, but on version 5 there is a ramp. We're planning on integrating the diffuser tunnels into the bodywork if possible, just to keep weight down. We haven't gotten to the point where we're channeling anything into the radiators yet. We have the radiators included in our assembly model, and we're working the bodywork around that, but currently it's just a large void in there. The intention, though, is to have a tapered shroud that leads into the radiator as a channel.
It's not really a question, but being on Aero team last year and going through the whole process and going to the competition, I realized that the aerodynamics of the car don't play a huge role in points. So I spoke earlier about the airflow and directing that airflow. I think I would just place more emphasis on being creative with the aerodynamics.
Right.
Because there's a huge portion of the competition where it's totally up to the judges on creativity. And I think all across the board, aerodynamics is all about being creative with your airflow and trying to do different things and try to make them change the rules for next year and things like that. So I think y'all are doing very well. We have a lot of good designs and good validations, and so looks good, guys. Good job.
One of the areas that we've been interested in pursuing, although we're not sure if the packaging will work, is a blown diffuser. And I know you guys are currently working on the exhaust right now. But one of the things that we were interested in is either using the heated air from the radiator or the heated and pressurized air from the exhaust as using the exit of that into our diffuser tunnel to increase the volume down there as well. We haven't gotten to the point yet where we can confirm, yes, this will work or not. But one of the things that we included in the rendition of the diffuser that we have right now, this area right here is cut out for the quick jack, but we're also using a floor to it. And that would act, we hope, to draw a lot of the hot air out of the engine cowl area. So you have a large area of lower pressure at the back that acts to draw all that through. So it is something we're considering.
Dr. Chang, Dr. Thunder, do you guys have any questions for me?
Okay, I do.
Yes, ma'am.
Okay, I know that you guys are, and it's pretty preliminary because of having to integrate weight a lot for those other guys to give something to you to work around. So for your CFD, what air model are you using? And then how do you expect that to change, or, well, it's a multi-part question. So first, what air model are you using and how will you validate your results at some point?
Okay. So, I won't be able to answer like specifically what air model, but I know it, like as Sean as he emphasized, we're using the very basic flow design in Autodesk Inventor. The envelope that we're putting on this model is adequate enough so that it won't impede our results, so that we can actually get just a basic validation of our design. For the future, we are looking into more for learning on the process of the flow design from SimScale. SimScale has a very in-depth in-depth knowledge on which boundary conditions we can set based on refining the gradients of mesh ratio, hybrid meshing. This is a very involved process. So to more specifically answer the question, we are currently investigating how we can actually perfect using the hybrid meshing, refining the meshes so that it won't keep us from stalling when we're running our analysis. I am aware that we have access to the supercomputer from the CADC. We are currently going through to see whom we need to speak to so that when we do have very, very dense refinements in the meshes, so that we can actually have that computing to produce that information for any inflated boundary conditions, for any high meshes on certain gradients.
Yeah, and in terms of validation, we've also been looking into 3D printing, scale model of whatever we have to finalize the design before we can do that. So if and when we do that, wind tunnel analysis or maybe a smoke screen just to see how the air flows around our body. So that's how we're going to validate our CFD, hopefully.
Part 2 to that one is, how do you think things will change between going from Houston to Lincoln?
Well, for one, I'd have taken into account the temperature. The temperature of the wind will take into account into the actual flow. For now, it's just going to be changing the temperature of ambient air for the actual flow in the CFD analysis. So for now, it's just being able to account for the temperature changes. Because we're operating at low speeds, it's not really going to affect us too drastically to where we're going to actually see a significant drop.
When I was doing a preliminary validation of the flow design software with SolidWorks, it did give the option of varying the inlet temperatures as well as the humidity. So we can take that into account.
You have to dig kind of deep, but we did this last year for the air intake. You can actually go, it wasn't weather.com, but it was something similar. You can dig through their archives and find like what Lincoln, Nebraska shows on average for temperature. Yeah, for like the past 5 years, something like that. And then we got there last year and it was like 20 degrees colder, but yeah.
How will we actually take into account for the changes in the environment?
Right.
And that's why that's how I was recapping on earlier, that we will take into consideration the temperature changes when we're actually running our CFD analysis, so that way we can verify all this information, so that when we actually have the physical test run, we can actually show that the numbers are matching to our expected analysis.
All right. That's
Thank
all
you,
the time we
everybody.
have.
Thank you.
Appreciate it.